The Mechanics of Man exhibition is being held this year at the Queen's Gallery of the Palace of Holyrood House as part of the Edinburgh International Festival. And the reason I was invited is because the theme of this year's festival is technology. What we're going to do is look at, in the exhibition, the pictures and anatomical drawings that Leonardo da Vinci did 500 years ago in trying to show the three-dimensionality of the human body. And we're going to now, alongside of these pictures, show the modern technology, how we really can see them in 3 dimensions using CT scans, MRIs, ultrasounds, etc. In other words, the most modern imaging technology that illustrates what Leonardo was trying to show. We have a wonderful collection of human prosections that have been plastinated after their dissection. So the detail of the human body is shown in intricate detail.
I was provided the MRI data, which is a DICOM data set. It's effectively a bitmap image, a grayscale image, generated by the MRI in slices through the object. Our software then takes those slices and joins up areas of the same grayscale. And so we can choose to have the muscle, which is one grayscale, or the bone, which is another, and it will actually physically join up those layers of equal grayscale to generate a 3D surface. The printer takes in a file called a stereolithography triangulated language, or an STL file, which is a surface model of the object we want to build. The software then slices that into layers, and each layer is then fed to an inkjet printer. So we have a set of inkjet print heads, and those actually print out a liquid resin, a liquid polymer, a liquid plastic. There's a light at the one end of the print head stack that will, as the print head goes over it, it turns the liquid resin to a solid. So it's using ultraviolet light. Well, we've got a number of heads, so some print out the build material, which will be your final part, and some print out a support material, which, because it's coming out as liquid, it needs somewhere to land. So the layers are 30 microns thick, so each layer adds 30 microns of the part. Keeps doing this from the bottom to the top of the part. When it's finished, you'll have your part embedded into a gel-like support structure, which we then remove using a water jetting process. The difference with this printing is that it had to be transparent. So there's a difference in the material we're using. The technology we've got will allow us to use either opaque or transparent materials, and actually we can grade between those as well if we wanted to.
The final heart in the exhibition will be alongside a very interesting experiment that Leonardo drew, and we will have the original Leonardo picture showing the eddy currents, and we've got a moving MRI showing exactly the same thing, and the heart will be shown to show that the chambers of the heart are what they're like as an example of modern technology. But in the future, it is likely that this technology is going to be used more and more. There was a patient who had a particularly nasty fracture of the pelvis, and that patient's CT scan was then 3D scanned so that the surgeon could actually have a look at what he was going to operate on before he operated. And it will be used more and more in the future.
It's great to see the application of additive layer manufacturing going off into other aspects, rather than just in engineering applications. It's great to see it in medical applications. It's also great to see it in the interface between the arts, humanities, and medicine and engineering. So yeah, it's brilliant.